Welcome to this training on the Modo particle system. This course is aimed primarily at the beginner and is based around 3 practical projects. If you are looking to get started using particles and dynamics in your work, then you have come to the right place. In the delivered materials you will find 5 videos. This first video introduces the basic concepts of particles and how they work in Modo. The second video looks in detail at the schematic editor. This is the main tool you will use when creating and manipulating particle systems. If you are not already familiar with the schematic editor, then I suggest that you take a look at this material before proceeding. In our first project, sparks and smoke fly as we look at creating a cartoon grenade with a burning fuse. It demonstrates how the Modo animation system can be applied to items in the particle system just like any other item. The second example looks at combining particles with the Modo dynamics system. We carefully construct things only to explode them. The results are well and truly shattering. The third and final project looks at an alternative way to choreograph particle behavior, as lava flows and smoke billows from the cone of an active volcano. As a bonus, we get to see how to create and sculpt simple terrain. So what is a particle system, and how is it realized in Modo? Here we are in the setup view with a blank canvas. Let's bring up the particle tools and create our first particle system. Let's add the item we've just created into the schematic and bring up the connected item. You can see already that there are 2 parts to this particle system, an emitter and the particle simulation. The particle simulation is the engine that manages the particles. It maintains a list of particles along with their properties such as position, velocity, mass, etc. And on each frame it updates the positions of the particles according to their velocity. Well, that's a lot of words, but what does it mean in practice? The first thing I'm going to do is change the way that the particles are rendered into our display. I'm going to change it to a distinctive color and increase the size of the particles. And this is to help them show up on the video. So I can run this simulation by pressing one of these buttons. The first button runs the simulation, but there's no notion of time. The little time marker is not moving along the timeline. The second one runs the simulation for the duration of the timeline and then resets and starts again at the beginning. But notice that we see no particles in our timeline at this point. In order to get the particles cached into the animation system, we need to use this button here. This caches the simulation for the duration that you specify, and now the particles have been placed into the timeline. And we can use the standard animation play tool to play back our simulation. So particles come from emitters, and we have several different kinds of emitter to choose from, and they feed into the particle simulation. Emitters are just one class of operators. Operators can be plugged into the particle system and they modify its behavior in some way. So for example, the emitters emit particles, but forces will act on the particles to change their velocities. And there are a number of exotic operators which belong in a more advanced tutorial. So I'm going to do a bit of particle doodling. We already have a particle simulation with a radial emitter. Supposing we add in another one. Modo automatically connects it up with our particle system. And now we have 2 radial emitters. I can move the emitter, and if we run the simulation, we get 2 sources of emission. If we wanted those in the timeline, we would have to cache the simulation again. Well, why stop there? Let's apply some forces to our particles. The forces live down here. We have wind, drag, curve, linear, radial, turbulence and vortex, to name but a few. Picking one at random, let's try a wind force. This force is going to act on the particles to blow them in the direction indicated by the arrow. As you can see, Modo has automatically connected the force into the particle system. So let's run it and see what happens. So our particles are now being blown upwards. Why stop there? I'm on a roll. Let's add a turbulence force. And now they're being blown upwards, but they're also going all over the shop. So you can see how adding items into the operator input, if you like, of the particle simulation, we can change the way that the particles move around in the scene. And just for fun, let's create a different kind of emitter. Let's try a surface emitter. There we are, plugged into the particle simulation. Now this isn't going to do anything because we haven't connected an emission source. Surface emitters emit from, well, you've guessed it, surfaces. So we will need a surface from which to emit. Well, we can create a simple surface. For the sake of argument, let's create a cylinder. I'll move it away from the other sources of emission and run the simulation. Nothing happens because, what have I forgotten to do? I've forgotten to connect the cylinder to the surface emitter. Drag the cylinder into the schematic, connect it in, and now the cylinder will also be the source of particles. We've got more particles than we know what we can do with. The particle simulation itself has a number of, if you like, built-in forces. We can apply a drag force, which will act to slow particles down. See, they're a bit less lively now. If we make this really big, then they're really reluctant to go anywhere. And we can also apply a gravity force. This acts in the downwards direction, as you'd expect from a gravity force by default, or we can imply gravity in the XZ directions as well. So gravity makes things fall down, as Mr. Newton discovered. So we've created our particle system and it's doing what we want. Perhaps now we want to actually render these particles into our final image or animation. Well, we're going to be in for a bit of a disappointment because the particles don't show up in the render. And that's because particles just simply are not renderable objects. They are essentially infinitesimally small points in space. In order to see the particles, we need to associate them with something that is renderable. And we have several possibilities. One of the simplest options is to use a replicator. Now a replicator is used to replicate geometry, so we also need to supply a prototype object. So let's add in something simple, a cube for example, and resize it to be relatively small. Now we can pull the cube into the schematic and supply the replicator with something to replicate, and the particles come from the particle simulation. And now we have a cube at every particle location, and those cubes are renderable. There they all are, in all their cubiness. If the particles are simulating something a bit more fluid, then we might want to use a different sort of renderable object, such as a blob. And now we can see that the blobs merge together to form a sort of gloopy surface. If we want something that looks a bit more cloud-like or steamy, then rather than use a blob, we might choose to use a volume item. And the principle is the same. We attach the volume item to the particle simulation and it replicates that item for each particle. But there's more. We're not restricted to having just one particle system. We can create as many as we want. Let's create our first particle system. And let's adjust this radial emitter to be emitting particles upwards. So far, so good. Nice big purple particles heading for the moon. But we can create another particle system. Add particles simulation. Particle simulation. And we can use these particles as the source for new particles. And the way we do that is by using this other emitter type, the source emitter. So I will add the source emitter into the scene. Modo has been a little bit over-enthusiastic about connecting it up, but that's easy to fix. We can take the particles from the first particle system, feed them into the second particle system via the source emitter. So every particle that comes out of here will be the source of a secondary emission for this particle system here. Let's see what that does. Brilliant. I can make that a little bit more visible again. Every purple particle emits a yellow particle, and that's not easy to say. If we make these particles have no velocity, then the effect is to create a trail. So that covers the basics of creating and editing particle systems. Obviously all of these items have multiple settings which will change the exact behavior. You can consult the manual system to find out the precise details of all of these settings. And the best way to find out how these things behave is just to play around with them and see what happens. I think we're now ready for our first project. See you on the other side.